All right. So what are we doing today? I'm going to be doing a Bitcrushing plugin using the Arbor framework. So we're going to be doing it in Zig. It's going to be cool. I've already played around a little bit with doing some stuff, experimenting with Bitcrushing plugins, specifically in Zig, although I did kind of do a little proof of concept in C, actually, just doing VST2, kind of raw, but this time we're going to be doing clap and VST2, and then this will get ported to, VST3 and audio unit as I eventually write those APIs and stuff. Let's see. Okay, yeah, so I don't have the repository that I was working on, which is fine because I want to start this from scratch anyway. So yeah, let's go ahead and start a new project from scratch. And yeah, let me make sure that text size is decent. I have to bump it up a couple notches compared to what I'm used to, just so that it's like decent. Keep getting complaints from YouTube about the bit rate. Yeah, I don't know why it doesn't do the full 6800, but whatever. I'm sure it's fine. Okay. And I already have a title in mind for this plugin. It's going to be called Arbor, because it sort of sounds like the name of the framework, and it also has bit in it. I'm going to go in there, and if you call Zig init, that'll generate some like boilerplate. It's kind of overkill for what we need. It does generate a Zon file, which is kind of nice, but that is also kind of easy to write yourself. So what we can do is just open our editor here, and we'll make a new file called build.zig. And then we can also make a new file called build.zig.zon. And this is your sort of package, the way you sort of interface with the Zig package manager, and the way you declare dependencies and stuff like that. So you just give it a name, and I'm pretty sure you have to give it a version, and it has to be compatible with the Zig semantic versioning format, which is just like you need to give it three pieces in the version. And then we declare our dependencies. And so we're going to depend on Arbor. And actually, an easier way of doing this is to run Zig fetch with the save flag. And so this will, this kind of works like, I don't know, I've never actually used like any of the cool languages and frameworks that have package managers like Node or Cargo or whatever, but my understanding is it works basically like this. You can sort of declare a dependency just like this, and it will save information about that dependency to a configuration file, which is our build.zig.zon file in this case. And you want to prefix it with git plus, which sort of tells it to that it's you're looking at a Git repository. So we'll go ahead and grab it, and I am going to just track the master branch, because I'm going to be kind of like develop. I mean, I'm probably going to end up making changes to Arbor as I make changes to this plugin. Hopefully not today. You know, hopefully we can just sort of leave the framework as it is for now, and it'll be good enough. But we'll see. Yeah, so you can go ahead and give it the master tag, and it will always pull from the head of the master branch every time you run fetch. Not every time you run zig build, as far as I know. So yeah, we run that bad boy, and you need to give a paths sort of struct in your Zon file, and that just is like the way that it generates a hash for your project, for your repository, for all the stuff that is described by the sig.zon file. In case you're writing something that will be pulled in by a package manager, this uses all the stuff in the paths struct to compute a hash for your thing. So go ahead and try that again. It fetched it, we reload, and indeed it has given us a beautiful dependency. So we can go ahead and close that, and we can start importing some crap. So you can just go ahead and import Arbor like this, and that will import all the stuff that's like declared in the build.zig file. So we need to make a public function called build with a build thingy. It may return an error, so we add that little exclamation point in front of our return type, and then all you really need to do is just call try Arbor add plugin. Don't want a P there. And then this is also where you sort of lay out the all of the sort of like description of the plugin that can be known at compile time. We just do it in the build script because that's kind of the easiest way to like propagate all that information down to the rest of the plugin. So let's see, I think there's a name, and that's Arbiter. The ID, which would be like a unique sort of bundle identifier, and that's, you usually want to sort of include like your company name and then the name of the thing, and then potentially like a format specifier, but I don't know if that really matters. I think something like that is just fine, just some sort of unique string, some hopefully unique string. Give it the company name. That's going to be Arboreal Audio. You can give it a copyright if you want. I will, because I enjoy, you know, all things having to do with litigation and legal entities, and you know, copyright and intellectual property and stuff. I think it's great. I'm trying to do this from memory. There's like a URL field. You have a website, you can embed that. And certain plugin formats will want this. Clap wants you to give a manual link. We don't really care about that. A lot of plugin formats will want a contact link, like a support URL. I do have one in this case, so I will fill that out. Okay, and then there's like a brief little description that you can give, a little sort of tagline or sort of catchy thing. Again, this is basically optional, but you know, there's nothing wrong with a little marketing, I guess. What did I call this one? A bit biting audio destroyer. It's basically what this plugin is going to be. And as far as features, there's a few basic ones you need to have. So if it's like an audio effect, you have to have the effect feature. Otherwise, there's instrument, and I think analyzer is the other one that you need to have, and that comes from like the clap requirement. You need to have like one of those three major features. I don't know how many I mean, yeah, I guess analyzer plugins are somewhat popular. But yeah, so this is going to be an effect. It's also going to be, I guess, a distortion plugin. And that is a predefined feature that we have. We also have there on a separate line, we have a stereo feature. In clap, that's like a specific sort of feature that you pass. Right now, it doesn't really do anything as far as affecting the channel layout. I think what we need to do in the future is kind of let this feature define the channel count. So like if you wanted it to be surround, which not supported currently, but you could do that, or you could do just mono if it is in fact a mono plugin. So we have features, we have root source file, and that's going to be the path to our like main plugin file that exports the main functions for our plugin. And then you want to give it a target, and this just has to do with like the this is basically just a way of like forwarding the options passed in at compile time on the command line. You could like override this and specifically say like I think you can just like manually specify like the OS like that, but I don't want to do that. Or, I mean, there's no real reason to do that. At least in this case. I mean, there would be other reasons for you to potentially do that if you only wanted to support one operating system, I guess. So that's basically it. We do need to create an actual plugin file so that we can like do it. And the main thing that you have to do here is just export an init function, which will return a pointer to an Arbor plugin. And in here, we're also going to have to define a like dinit function, which takes a pointer to the plugin. And let's just make an alias for plugin, so we don't have to keep typing arbor.plugin. And we'll just discard that for now. There's a prepare function, which gives you a sample rate and a number of audio frames. And we can discard those for now. You mainly want this function if there's like any sort of like state that's going to be in your plugin. So if you're doing like filters, you're going to need to know about the sample rate. If you have delay lines, you're going to need to know about the sample rate and possibly the total number of frames that you're processing in a buffer. I'm still seeing a warning on OBS about the bit rate. I mean, if the quality's bad, like feel free to spam about it in the chat, I guess. I don't know. sure it's fine. Okay. And then the last function we need is a process function. And this, we have a audio buffer of F32s as the input. Okay. So then in the init function, one of the main things that we need, or yeah, basically the main thing that we have to do is call Arbor init. And this is where we sort of give it information about our plugin. Typically, I like to define an allocator that is going to be kind of the main allocator that we use. I'm just going to go ahead and import the standard library and define. We're just going to use the default like C allocator. So you got to pass it the allocator that you're using, a slice of parameters, which if you don't have any parameters, you can actually just give it an empty slice and it like won't care. And then you just pass it pointers to the functions that you have defined, and that is basically your way of sort of defining the defining your implementation of a plugin's interface. That's sort of how we do like object-oriented programming in Zig, is just by sort of writing our own interfaces, which are just sort of bags of function pointers. So this should compile and like basically be like a real plugin. Expected 2 arguments, found 1. Oh, what am I missing? Oh, because it's oh, we pass it a pointer to the build struct so that it like has context. Missing struct filled version. Oh yes. As it is right now, there's no way to get the version from your Zon file. That's just sort of like there, I think, just so you can see, you know, like what version a package is, but it can't, as far as I know, there's no way to like propagate it down to your application. But that I might be wrong. I don't know. But anyway, we'll just copy that here. And this doesn't have to have the full semantic versioning. Like you can omit the patch and it'll work fine. But I just like to do it like that for consistency's sake. Okay. Looks like we're good. Okay, so we should have, we have a clap plugin and we have a VST plugin. Let's go into Boopwig and see what the situation is. Now it's not going to like process any audio or anything, but as long as it loads without crashing, it's going to be cool. Okay, so here we have the empty plugin down there, and the VST2 also loads. Excellent. So that's pretty cool. Yeah, so we wrote about, no, that's like less than 20 lines of code. This whole file is 28 lines, and we don't really have anything in it, but yeah, you can write a pretty small amount of code and get a working plugin up and running. I think in the future, we're probably going to need to there's going to have to be probably more stuff in this interface. Maybe some like optional functions that like you could just leave them undefined. But like there's a lot of there's a lot of stuff with MIDI that is not implemented yet, and then there's a lot of like kind of interesting stuff that Clap has that, you know, I want there to be like options for users to define their own implementations of things, and so that's going to be kind of interesting to see how that gets figured out. So yeah, let's go ahead and first of all, let's start giving it some parameters. Now, if we're making a Bitcrushing plugin, I mean, like kind of the main thing you're looking at doing is, you know, reducing the bit depth of the audio. So what you get in pretty much every plugin that I'm aware of is you either get 32-bit or 64-bit floating point. Currently, we're just working with the 32-bit because that's just the easiest to just implement one process function currently. So you get 32-bit floating point in, and the idea is that it's supposed to be scaled between the ranges of 1 and -1, and that's just sort of like, it's just an easy way of normalizing floating point data along sort of a bipolar axis, because audio is not necessarily bipolar, but it's, the idea is for it to have polarity. So, but another thing is that, you know, CD audio is 16-bit, and when you render like a WAV file, I don't know why I said CD. I mean, I doubt anybody who will ever watch this even knows what a CD is. But you know, if you're like mastering a mix, you're probably doing that in a WAV file, maybe FLAC if you're you know, a weirdo like myself. But those are fixed point integer formats, either 16 or 24. And so what that actually does, or you've got basically the maximum value of a signed 16-bit integer. Let's see if we can get it here. So yeah, max I16 max. What is that off the top of my head? I don't know. 1 shift left by 16. Oh, but you only have you have half of that, right? It's 1 shift left 16 divided by 2, because it's you know, they say 2's complement. So yeah, that's what that gets you. It's about 32,700. And that's on the positive side, and then on the negative side, it's like whatever, 32. You get +1 because the on the positive side, that's like the extra bit is taken out by the sign. So you're kind of in between this range if you're in 16-bit audio, fixed point. And so that does give you less dynamic range than if you're working with floating point stuff. But effectively, I mean, you get so much dynamic range that, I mean, if you listen to a WAV file, it's like you can't hear the noise floor unless it's like a very quiet file and then you amplify it dramatically, and then you might be able to hear the noise floor on 16-bit. On 24, I mean, it's even harder to hear that noise floor. So one thing we could do with a Bitcrushing plugin is you have like a number of bits parameter that starts at 16, which would be like kind of the highest kind of the highest threshold of what you would imagine as far as like reducing the dynamic range of audio, and then allow you to slide it down from 16 all the way to like 1 bit, where you basically only be, I mean, 1 bit would be kind of impossible to, you can't replicate positive and negative. But I mean, you could technically have like frequency there. It's just either it's 1 or it's 0. So let's make a set of parameters to start. Okay. Let's make an alias for the params namespace. So we can call param. Let's make it a float just so that it's, because if you make it an int, sometimes that that'll make it so that there's like an option menu, that like a drop down menu that comes up in certain certain hosts. So let's call this bits, or should it be like bit depth? Yeah. Bit depth, minimum is going to be 1, maximum 16. The default, we could set it at 8 because it's a nice sort of halfway point. And it's also, that's sort of the threshold at which you'd like start to hear artifacts. I mean, that's not true. Even like 12 or 10, you'd start to hear some artifacts. Okay, so I made it an int, didn't I? Let's make it a float. I really would like to just make it a float. So we've got a float parameter. Okay, and then we have to pass that in here so that it knows about it. All right, let's just make sure that that like compiles and will show up as a parameter. And it does. So we have this continually adjustable bit depth parameter. Excellent. So now you kind of want to think about like how this is going to be implemented in processing audio. So if you're going from a floating point range, we have either 1 or -1, and then everything in between is some kind of decimal that is less than 1 and greater than -1. You can kind of see those numbers as like fractions, or as like a percentage of the maximum possible amplitude of an integer representation of audio. So if we did, if you do 1.0 times the max of an I16, that'll give you the absolute maximum value of a signed 16-bit integer. So if you have audio that would clip in floating point, it would also map onto that clipping point of 16-bit audio. And then from there, you kind of, I mean, you can do the same thing for negative stuff too, right? The minimum of an I16. So, I mean, really from here, all we just have to do is just take our incoming audio and basically check if it's positive or negative. And then from there, you can just multiply it by either one of these maximums. And that will basically convert the audio to fixed point. But if we want our bit depth to be variable, I mean, you could probably do something sort of wacky where you like, you get the bit depth value. So, I mean, we can just go ahead and actually get that here by, let's see, get param value. So we'll get the parameter value as a float. And so like if you did, if you like rounded this to an int, let's see. So if you did like int from float, so that would get you basically just the integer part of the floating point number. And then is there some sort of built-in function or something that would, where you can like check, where you can like query like the number, like the size of something, the size in bits. I think there is bit size of, but I mean that's kind of bit size of t. But there's no way to generate like an integer type from an int itself. Like there probably is if you in like the built-ins or something. But well, I don't know if that's really going to be the best way to do it. Because all you really have to do is just look at this bit depth. And then if we know the maximum is 16, we can just basically subtract whatever we're at. So if we do 16 minus 8, if our parameter is 8 and we know the max is 16, that'll give us 8. A bit depth of 8. And we know that we can find the maximum value of, you know, a fixed point integers by just bit shifting. So, and I think we want to actually go 1 minus that, right? Because if you do 1, yeah, because it is signed, so we have to account for the fact that we're signed. So we have this sort of a resulting number here. So if we do 1 bit shift, you know, 8 minus 1, that will give you the maximum value positively. Now, as far as the negative side of the audio, if you shift right, if you do a signed shift right, I actually don't know what happens. Does it wrap? Does it go in that direction, or you need to have the negative bit flipped, right? I mean, I suppose you could just use this 8 minus 1, or, you know, the sort of number of bits minus 1. And that will always be, you know, 1. Well, that would be 1, because you only get 127 in a signed 8-bit, right? That you're between 127 and negative 128. Okay, but I mean, if we know that it's always going to be, we shift left by that number minus 1 minus 1. Well, not shift left, but you minus 1. You do something like this. So you do minus 1 after the shift left. So that'll get you the maximum amplitude on the positive side, and then the minimum amplitude would just be, oh my goodness, would just be this, right? Do I have that right? That's just my sort of, you know, back of the napkin math from, you know, caveman brain. But that seems to check out to me. I guess we can just try and implement it and find out. So yeah, let's go ahead and compute some of that stuff. So we'll make a sort of positive max. And that's going to be 16 minus int from float bit depth minus 1. Okay, wait, no. It's int from float minus bit depth shift left by, okay, no, wait, hold on. Because we want the result of this. So this is like kind of the actual number of bits that we're using. I just realized I deleted the brackets around process. What the heck? Okay. So that's the actual number of bits that we're sort of that will give us our amplitude limits. So the let's just call it max, because it is basically max. That is 1 shift left by bits minus 1 minus 1. And the minimum is 1 shift left by bits minus 1. I always type cosnit instead of const. So painful. Okay. So now we have like a min and a max amplitude. So if we have a floating point number, f, if we check its sort of positivity, then we would just do f times max. And that'll sort of remap our floating point number into like an integer range. And then, oh, that's not how you do a ternary statement. And not that Zig even has a ternary statement, but I'm just sort of writing it out just to make a point. So otherwise you multiply by minimum. So let's actually loop over our channels here. Okay. Oh, this needs like some sort of let's see. Yeah, what type of integer should this be? The U32? Maybe, I don't know. That might be it might complain about that because of This needs to be negative too. It might complain about that because Zig wants you to be like very specific about the bit size that you are shifting by. So if you're like greater than log2 of the operand, I guess, that's like a compiler, but we'll see what happens. So let's make a copy of the input. I like to call it X usually. So we'll copy the input sample. X is greater than 0. X will times equal the max amplitude. Otherwise, we will times equal the minimum amplitude. All right, let's just hear how that sounds. So we have the right to the buffer's output here. We're just going to say it's X. We can't do this quite yet, though, because that's going to convert it to, we converted it into an integer range, which is well beyond the limits of floating point. Oh, maybe you did math sign will return 1 or -1. Oh, where do you mean? Like, oh, like just check the sign of the, check the sign of the input and then, oh, yeah, I'm not sure. Yeah, I don't think that's, yeah, because all I really want is either like, you know, for 8 bits, I want positive 127 or negative 128. Let me just double check that my math is correct there. So 1 shift left by 7 is 128, and then I just negate that. And then, so if I do like 1 shift left 4, that'll give me 16. And then if we do that for the positive side, we get positive 15. Okay, so yeah, so we remap to the integer range. And basically the way that this actually like turns into bit crushing is you just sort of lose, you lose dynamic range by basically like snapping to like the closest integer value. And so that results in like aliasing. And we can like load it into a, if we load it into the like wave shaper graph in Plugin Doctor, we'll be able to kind of visualize what's happening. But first, before we do that, we have to actually convert back to floating point. So we remap onto the integer range, and then we have to, then we basically just have to divide ourselves by it again, right? So that'll be like kind of a separate check, because you presume that there's going to be like audio processing happening here, crazy, you know, fixed point stuff. I have some cool stuff in mind for what we're going to do there. But yeah, so we check for positive, and then this time we just divide by the ceiling. And so technically, like, these are all like floating point operations, but we basically simulate fixed point by doing this, by doing these things. Okay. Let me just do like a quick little napkin math just to make sure this works out so I don't destroy the speakers. So let's say we have an absolute, you know, our loudest sample incoming is 1. and we multiply by 255. You got 255. Okay, we won't be doing that. We're going to be doing it by like 127. So that will give you a value of 127. And then so we do 127 divided by 127. That'll give you 1. So you're remapped back onto the floating point range, but you know, in the event of if you have like 0.5 times 127, that's oh no. Now everyone's gonna know I'm bad at math. As if that wasn't already obvious. 63. Now one thing we actually might want to do here though is like create a temporary integer so we can do like integer division so that we don't so that we lose precision, right? But for now, you know, this should be good. So yeah, we do. It's actually, yeah, because we don't actually want to do we want to do floating point division so that we can have a decimal. But when we do this multiplication, we want to round. So you'd want to do like x equals x times max, but then you want to round the result. And I think so round, we'll round away from 0, and then trunk will round towards 0. So I guess we don't know. I'm not sure which one is like more. I don't know if there's such thing as accuracy when it comes to bit crushing, you know? Yeah, I don't know if there's like a canonical thing that you do there, but let's go ahead and just make this an assignment. This is kind of like, I guess this is sort of Zig's version of a ternary. It's not a ternary statement, but it's you can turn an if statement into an expression like this. So we can just assign to x the result of one of these equations depending on our condition. And then again, okay. We should be, yeah, okay, so this is what I was talking about. Must be a fixed width integer type, or right-hand side must be comp time known. Okay, yeah, it doesn't like you to use comp time integers as the like operand of a shift. So we want to just make this like a predefined integer type, fixed width integer type. I guess U32 should be fine. It'll give us enough sort of like headroom to shift. But yeah, okay, so we don't really want this to be a U32 because it won't let you shift a U32 by a U32, which makes sense. I mean, that's sort of a nice like safety feature. So I mean, if our max bit value is going to be 16, what is that? Like, what is that, 4 bits? We can even just like explicitly type this here. So now we have no more than 4 bits here. U4 cannot represent integer value 16. It can't? Wait, what? Am I stupid? What's wrong with me? Wait, why don't I get it? I guess I'll make it a U5, but I mean, what? Huh? I'm still a little confused, but oh yeah, we don't want to make this a yeah, we want those to be signed, right? F32 and I32. Okay, yeah. So then we do okay, yeah, no, we want to just cast it here. Let's just go ahead and make that here. And so we use that as our multiplier. Okay. Okay. We have compilation. All right. So we're in big wig or whatever this is called. Let's grab a drum machine thingy. Start loading in some excellent samples. You need a kick and a snare, and you need a let's find something weird. Cops? What the hell? No. Creatures bells. That's cool. Yeah, I like that. That's gonna sound interesting with a bit crusher. Let's make a little MIDI loop. Let's make it a little longer here. I think snare on 3 is kind of the way to go. That's kind of weird. All right, I think that's fine. And then we, that's so annoying sounding. That is very weird, but I think that's fine. Let's make the kicks. I don't want to get too caught up trying to just make a cool beat, but let's see. Okay. The snare is very weak. That fucking bell is so terrible. Okay. All right. Let's load it in, see what happens. Nothing. And it crashes. Just weird spikes in the audio, yeah. That's not good. I think we probably want to include 0 here, but that I don't think that really accounts for I don't think that necessarily accounts for the artifacts that we're hearing. Not artifacts, but it's just like the samples are only occasionally producing actual sound. Do we just want to multiply by the minimum? Oh, wait. Yeah, so if we do... We have like -1. We multiply by... we have -1, we multiply that by -128. That gives you +128. Which is not what you want, by the way. Yeah, because I swear in it, when I implemented a Bitcrusher before, I didn't use a positive and a negative side, and now I'm realizing why. I mean, one, because it's just easier, but two is because yeah, you actually get this negation thing. So if we just don't negate it, right? If we don't negate it, then that should map you onto the right range, I would think. Let's delete that. This is not a good beat. Yeah, it's still just squelching, and then it crashes. So the crash is probably because of like integer over... No, could it be integer overflow? I mean... This doesn't need to be signed. And I mean, it doesn't need to be a U32 either. It really needs to be, you know, a U4, but for some reason it didn't like that. I don't think that'll compile though, because it's now we're shifting by too much. Yeah, screw it. Let's just do it. 32. If it comes to it, I'm just gonna have to copy my the other Bitcrusher that I made. And yeah, I did it just from, you know, from first principles, as they say, but it went a little easier than this is. Actually, let me pop out the chat. Can I do that? This is a control panel. Can I pop out the chat, or is it just like it's a desired result to clamp between 127 and -20? If our bit depth is if our bit depth is 8, then yes. That would be the desired result. The issue is we need it to be like variable bitrate. I really can't narrow this thing. Okay. Yeah, so we need it to be like variable bitrate. So we have to like compute the maximum integer value, like in the processing or whenever our parameter changes, but it's easier to do it in the processing function. Yeah, I'm pretty sure what I did before was just, well, I guess we don't want to truncate here, but that still doesn't really, maybe use math clamp, f min x math. Yeah, clamping won't, because if you do, so you're saying like, yeah, so if I say clamp x to between f min and f max, what that will do is if we're greater than if we're greater than like 127, it'll clamp it to that, but the floating number is never going to get to that point, you know. Yeah, and if you look at they even have a little wave shaper here. That's cool. Yeah, so actually what that does is just says max of the lower range and min between the value and the upper range. I mean, we could clamp it after this. I don't think that I don't know if that really makes like a difference though. Like it should already be clamped, you know what I mean? If we assume that the max float is, oh, one thing we probably should do is clamp x between 1 and -1, like clip it. And then I guess we just like, yeah, I mean that clamping, that second clamp call is like basically not gonna do anything. Hmm. All right, let's try it again. Let's hit play on this terrible beat. Well, now it just crashes outright. Might have to actually debug this. Debugging Bitwig is like really hard though. Might have to launch Reaper, which is much more cooperative, but doesn't have as much in the way of like MIDI like ways of generating your own sound. Yeah, I kind of just want to see why it's crashing though, because that's weird. I don't know why it would be crashing unless it's like something where the like floating point number is like out of bounds of the integer. I don't really know. Okay, so let's... Okay, so we're gonna need to, let's just make like the synth and slap something in here. Hopefully that's not like crazy loud. I'll try and keep it down and make it like not a violent ear-piercing tone. Let me just check the volume. It's probably a little annoying, but let's make it like a pleasant triangle wave. Although you won't be able to hear the aliasing as much there. Okay. Okay, we have a crash. Unreachable code. Oh, what? What does that mean? I mean, I know what it means. It means we failed in the cert. This failed. Interesting. Okay. Is it because I'm truncating the... No. Truncating rounds is towards 0, right? Yeah, so that's like not... Oh, I know what it is. It says it asserts that minimum is less than max, which it's not. We want to clamp it to negative fmin. I probably didn't need to relaunch it, but that's all right. C3 seems like a pretty reasonable choice. Aha. Okay, now we have a crash there. If we go too high, integer overflow. Okay, so the creation of the maximum bit value. Bits minus 1. Oh. Yeah. Right, because if we give it 16, 16 minus 16 is going to be 0. So if we do bit, we can't do 0 minus 1. Yeah, I don't know. The minus 1 thing felt kind of dirty. I didn't actually do that last time. Okay, the level's good. I'll play 4 kilohertz next time and let me know how that sounds. No, but so I mean, you're not going to get like accurate clamping. You're not going to get accurate like an accurate level, but like I'm pretty sure the way I did it last time was just by doing a 1 shift left by bits, And yeah, I mean, that gives you an extra bit of precision, right? Unless we just do 15 minus the chosen bit depth. No, because that'll give you a negative number if we have a selected bit depth of 16. Yeah, I'm just wondering how to do that without messing it up, but yeah, so or we do 17. We do 17 minus 1. Right. So that way if we have an input of 16, we're going to shift left by 16, giving you the correct amplitude, I think. Shift right by 1 afterward. Afterward when? Because that would just like oh, you mean like get the yeah, I mean, I guess like either way, right? Either we just do 17 minus our selected bit depth or we do that, but yeah, I mean, this should, famous last words, but should work. Right, let's do it in Reaper again. All right, fingers crossed. It's almost having the opposite effect. Because 16 should be like our highest. Ooh. Is it? Oh, is it going in the opposite direction? Again, hope that is not too loud, but okay, yeah, no, that's at like minus 40. It's very loud in my headphones because I have the headphones volume kind of up. Okay, well, we're not crashing, which is pretty nice. Let's see if we can. Do I have plugin doctor in here? What gives, dude? Oh, it's gonna harangue me for a license. Oh my god, dude. All right, hold on. Should be able to load our VST version. Okay. Yeah, it crashes. Great. Yeah, so it is still like kind of unstable. I wonder why it crashed Plugin Doctor but not Reaper. Is it just a VST thing? Seems like it might be, yeah. Memcopy arguments have non-equal lengths. Oof. Um, let's see, where are we? Dispatch. Yeah, okay. It's trying to copy the parameter name. And yeah, so I did something with the string length. Yeah, they only give you 8 characters for a parameter string in VST2. We can kind of like circumvent that. I don't have it. Okay, yeah, I am being nice and official here and not using a I'm not like cloning the actual repository so that I can make changes and stuff to it. I guess we could just ignore VST2 for now, as most people are in 2024. But hey, I think it's a good format, despite its limitations. All right. So we can't load the clap plugin in Plugin Doctor, unfortunately. So we might want to patch. We might want to patch the VST2 bug, or at least like rewind to a different commit or something where I had like a different implementation of the parameter name thing, but I'd rather just fix it, obviously. So, but our bit depth is not really getting set accurately. We're like not losing, we're not gaining fidelity by increasing the bit depth. Let's go into Bitwig and like test it on some drums, which drums might be kind of a better thing to test. Like bit depth, like dynamic range reduction, since they have more of a transient sort of quality. Let's just load a single drum and not get too carried away making crappy beats. Let's see. All right. Yeah, so we lose bit depth as we increase the parameter, which is not right. So I think that's because we're what am I doing here? Why am I doing 17 minus the bit depth? What was the reasoning for that? I don't remember. We just want to shift left by the number of bits, right? Or by the number of bits minus 1. Like what happened? Right, so we input a bit depth of, like, let's say 16. We shift left by 15. Hello there, Freyskin. So we shift left by 15, and then we subtract 1 from our ceiling there. So we do 1 shift left 15, and then you minus 1. So that gives you what you expect from the ceiling of a signed 16-bit integer. So if we shift left by 8, or we shift left by 7, sorry, that gives you what you would expect from a assigned 8-bit integer. And then, I mean, same for like the negative side, right? So if we do 1 shift left 7, if we treat that as the negative, if we do negative 1 times 128, that'll give you a value of negative 128. That's your minimum integer value. Yeah, so I don't know what happened with the doing the max bit depth minus the current bit depth. I don't know what that was about. Oh, I don't want to. Let's just do it in Bitwig and not Reaper. Quit. All right, so now you can actually hear like the effect of the Bitcrusher. So at 16 bits, it's like, it sounds pretty normal. And then if we go down to like 10, you probably can't hear that over stream because it's like very high frequency noise. But it's just, there's like a subtle layer of noise there, and that's it hitting that raised noise floor of only having 10 bits to encode the audio, a simulated 10 bits. If we go down to 8, you can probably hear that. There's like a little sort of buzzing sound. And then if we keep lowering it, you get this pretty sick sound, honestly. That's awesome. Yeah, so like, you can get kind of obscene with it. I mean, 2 bits is like pretty silly. It is an industrial banger, yeah. You can just put it on anything, and like it's kind of automatic, like you know, automatic industrial, automatic noise music. So, like, one thing you can kind of observe here is like, as you lower the bit depth, that sort of obviously increases like the amount of distortion, the amount of distortion you're getting. If you lower the volume of a sound going into a bit crusher, though, it's going to get quieter, so we kind of have to compensate for it. That also kind of increases the crunch. And that's because it's like, as you bit crush, you lower your dynamic range, but you also kind of like lower the point at which it can actually like encode audio. That's typically what you refer to as a noise floor. So if you kind of like, it'd be easier to do this with like an illustration or something. Or if I could load it in Plugin Doctor, you could kind of see how it sort of aliases. Did I just load up a GIMP and draw something kind of silly? Oops, I did it. It's opening. It's opening on its own. I didn't click on it. Folks, technology these days. The sad part is you have to see the drawing now. All right. You have a sine wave. Let's suppose you have a sine wave somewhere in the world. So, you know, it oscillates like this. You have a max amplitude, you have a minimum amplitude, and then you have some sort of like center point, which would be a value of 0, regardless whether you're in floating point or integer. There is a 0 where there is no amplitude whatsoever in positive or negative direction. Yeah, so when you're in floating point, you're between like 1 and left myself a lot of room here on this wonderful little chalkboard. Oh my God, this sucks. You know what I mean. You're between -1 and 1. And then if you have like, say, 8-bit integer, you're between 127 and -128. So that gives you only 127 values in either, or 128 values in either direction that you can use to represent audio amplitude. And then if you just keep reducing that, you have fewer and fewer values that you can use to actually represent audio. And it doesn't so much as limit the amount of headroom you, I mean, when you're talking about limiting dynamic range, whether it's up or down is like kind of relative. You can limit dynamic range upward by clipping, and you can limit dynamic range on the bottom end by, for instance, bit crushing. So if you're in like, I don't know, 4-bit fixed point situation for some reason, I keep forgetting, is it 16 is the maximum? Yeah, but that would only give you, that gives you 16 total dynamic range. So you actually, if you're in 4-bit, let's just be dumb and assume you have 8 in both directions. It's not actually true. I don't want to be dumb. Hold on. I hate this. You have between 0 and 7 on the positive side, and you have between -1 and -8 on the negative side. So let's try and erase our sine wave here. Let's see if we can do that. Probably would have been nicer to like draw like little like a Bezier path with like a nice straight graph, but my computer's not good enough to do that. I only have GIMP. I know that GIMP can do that, but I'm gonna be dumb about it and assume that it can't. Okay. So like, what if we're in this 4-bit situation? We're in a very desperate situation where we only have 4 bits to encode our audio, which is actually like, as a little aside, some of the like lossy audio codecs like MP3 and stuff like that, they only use like a few bits to actually encode the audio, but they're able to get such good quality out of it by doing like insane signal processing and you know, mathematical devilry to sort of take advantage of perceptual I don't know, idiosyncrasies of like how we perceive audio to basically cheat and get away with only like a few bits in encoding the audio. So like if you have like a 200 something bit MP3, sorry, 200 and something kilobit per second MP3. So if you have 200K, that's, sorry, 200K is 200,000 bits per second. If you assume a sample rate of 44,100, that only leaves you with 4.5 bits to actually encode the audio. So even like a decent quality MP3 only uses about 4 bits, but that's not really related, or it's, what we're doing is like, it's definitely the opposite of MP3, where we're just sort of very uglily just throwing fewer and fewer bits at audio and then encoding it with that. So let's say your sine wave like doesn't actually reach full amplitude and it's just sort of like hanging out at kind of a low amplitude. We send in a low signal. That also kind of effectively reduces the amount of bits you can use to encode it. And so you can kind of reduce the dynamic range in 2 ways, or increase the noise floor in 2 ways, by either lowering the bit depth or by lowering the volume of the input signal. All right, so let's quit this terrible program. And what I want to do now is introduce like another parameter, which will effectively be like a gain control, but we'll call it like noise floor. And so what it's going to do is turn down the volume of our signal coming in and then turn it back up after the bit crushing, so that it effectively just sort of like underfeeds the bit crushing process, so we can actually raise the noise floor. As I spill water all over myself. I've got a drinking problem, folks. So create another float parameter. We'll call it noise floor. So all we're really going to be doing here is it's going to be something from like 0 to like minus, I don't know, let's try like minus 16 dB, minus 18. At lower bit depths, you're basically going to get nothing if you lower the gain that much, because you have just such few like data points. So let's say that it's between negative 18 and 0, with a default value of 0. The flags are going to be default. You need a comma there. Okay. So let's get that value. And, okay. We can go ahead and apply that like before we have to convert it from decibels first. When you just add noise to that bit depth noise floor, so minus 96 dB noise at 16 bits or whatever. Yeah, I mean, I guess that would be like, yeah, a more accurate way of doing it. Like if you want to explicitly specify what the noise floor is at. I guess what I'm kind of more interested in is like what happens if you like underfeed the bit depth, like the bit crushing process. So I guess we probably can't list it in like a decibel manner, because it's like technically what we're doing is not describing the level of the noise floor. So yeah, you are right about that, but I don't know what I'll call the parameter, I guess, but I do basically want to do it this way rather than just adding in noise, because that's like, I don't know, I guess I just think this is like cool. So then we just need to make it like linear. So we do, is it 10? we do 10 to the power of floor times, or, you know, divided by 20 or times 0.05. And then, yeah, so then we multiply by that, do our bit crushing process. And then if we divide by that, we'll reverse that gain process. And it doesn't work. Expected 3. Oh, well, it wants a type, I think. Okay, let's launch Bitwig again. What is this? I think this is what I made for the other day. Yes, it was. Okay, this is a fine thing to use. Let's take the example distortion off, though, and we'll throw on our bit crusher. Yeah, so you'll notice if we're at 16 bits and we lower the noise floor, like nothing really happens. If we go down to like 10 bits, you can start to hear that there's like this noise being added in. Yeah, I'm not sure what I should call this parameter. Maybe just like underflow or something? It's got to sound cool though. So yeah, then if we go down to like 8 bits, you can get like a pretty cool sort of raunchy distortion. And we can actually you can actually kind of back off with this noise floor a little more finely. But that sounds pretty cool. That sounds really cool. And then you can do crap like that. Hopefully the audio is still coming through. It is. According to OBS, at least. So if we go down to like 2-bit, I mean, you basically get nothing at 2 bits, and I don't even think we should even allow 1 bit, because I think that just produces, it produces like I think it just produces DC, because you're not getting any polarity, you're not getting actual alternating current. Or we should just like throw in a high pass at like 10 hertz so we filter out any DC. And yeah, we need like, oh, we just killed the output. Okay, we're back. Yeah, so at 3 bits, it's like you can barely encode the actual audio there. Let's hear what that sounds like on drums. Eight bits is kind of the sweet spot there. Although if we did like 6 and then raise the noise floor just a little bit. So that's kind of like, let me turn that down a little bit. So that's kind of like 2 different ways of adjusting basically the same parameter. Ah. Hopefully it's not stuck on Baitwig anymore. Yeah, okay. I think we're good. All right. So now we implemented that. What else can we do in Bitcrushing land? I did want to do like a, what do you call it? Like a downsampler, where it would just be like a very kind of crappy, very sort of like crappy downsampler where we just like discard every other sample, or we discard like every 4 samples or something, and you allow you'll just have some sort of like integer that defines like the downsampling level. Or we could pick like we could pick like a lower Nyquist frequency, but I think that just downsampling by like 2 or 3 or 4 up down to like I don't know, 8 times or something, that could be kind of cool. But while we're in the realm of sort of like treating this audio like it's an integer, there's like some interesting things you can do by like kind of messing around with by actually turning it into an integer like in data, and messing around with like some of the properties of integers in computers. Maybe you know what I'm alluding to, maybe you don't. But basically, like, there are these bitwise operators that you can do in with integers on computers that you can't do with floats because of the way floats are stored in memory. So if you have like a set of bits, let's I don't know, let's just make like a nice. Should I go back to GIMP? I don't know. I don't really like GIMP. Let's just stay here. So if you have like a set of bits, you know, a set of like 1s and 0s. I don't know how many bits that is. Go from column 4 to column 13. That's 9 bits. Or is it 8? I don't know. We got like 8 or 9 bits there. Yeah, so I mean, we represent numbers in computers by storing them in bits like this. And you have to represent floating point numbers in bits as well, but they kind of mess around with like how they're stored in order to get a lot of dynamic, in order to be able to represent a wide range of numbers with floating point values. I don't know exactly how it works. I mean, you've got like a sign bit, and then you have like a in 32-bit, I think you get like 8 bits for the it's 8 bits for the exponent, and it basically just stores numbers in like a format in sort of like scientific notation, where it'll be like some decimal number times 10 to the power of, you know, some other number. I'm pretty sure that's how they do it. And so you can just represent, you can represent large numbers like that. So that's whatever, I think that's what that is. Or you can represent actual decimal numbers like that too. But they don't, you know, C and Zig, they don't let you do bit shifting operators on floating point numbers, because I don't know, I guess it would just be it'd be kind of like funky, and I don't really know if there's any utility to doing it. So supposing this is like a 32-bit number, which is not, but pretend that this is a 32-bit number here, an integer. No, let's pretend that this is a 32-bit floating point number. What we can do is basically just, there are certain operations you can do to like tell the compiler to sort of pretend the that this number is an integer. You can bit shift on the exponent of a float. That's useful, but the mantissa not so much. Oh, okay. How do you bit shift? Oh, so do you have to like manually extract the exponent and then bit shift that? I guess that, you know, that'd be decent for like, yeah, doing exponential operations. I don't know. I mean, I know the, well, yeah, what I'm about to, oh, okay. I've seen that function, but I've like never, I don't know if I've ever used, if I've ever used that. But yeah, I mean, I can imagine that would be useful because that's like the only like, that's like the actual integer portion of the floating point number. So yeah, that makes sense that you can do that. But yeah, but so what, another thing you can do is just tell the, you sort of reinterpret the memory that your floating point number lives in as an integer. So we just said like, oh, this is an unsigned 32-bit integer. Now we can do bitwise operations on it. So like, if we took that number and we shifted it left by 1 bit, that would, if it were an integer, would divide that by 2. And as a floating point number, that would do something. I don't exactly know what. It might change the sign. You're definitely, you obviously, you lose data. Something's going to go off the edge and not come back. You can also do like other bitwise operations like an AND. So we could do like a bitwise AND with this and some other U32. We could do a bitwise XOR with a different number, or you can do a bitwise NOT. And what the bitwise NOT will do is it basically, and I'm actually just, I might be wrong about this, but bitwise NOT just gives you all the opposite bits, right? That's not X, because XOR will give you, XOR is relative to another integer. So this is not, and if you like XOR this with something else, what that would give you is all of the bits that are not shared between the two integers. So we could do like some crazy stuff with like, I don't know, correlating the left and right channels, or you could hold on to like the last sample that you got and then like XOR it against the last sample, or do a bitwise AND or a bitwise OR. And that may be cool. It might be a disaster. It might destroy your speakers. In, you know, keeping that in mind, what I do want to do is quickly implement a DC blocking filter so that we don't send out like massive DC spikes that will, you know, take out the entire North American power grid. Yeah, so let's do that. So let's just give ourselves a filter. Let's call it DC block. And yeah, so we're gonna have to create some like a user pointer now. Okay, so we can call this user, we can call it self, doesn't really matter. Let's just make like a type. So self is going to be a pointer to our plugin, Arbiter. So we use the allocator to create it. And since this function can't return an error because it's like exported and it's the C ABI and you can't return, you can't use Zig's like error union type. We just have to catch the any error that this throws. So if it does, we'll just log a fatal error. Zig looks pleasing to the eye. Yeah, it is. It's not as like visually tantalizing as Odin. I don't know if you've seen Odin, but that's like really kind of gorgeous to look at. But yeah, Zig is nice. I mean, it's nicer than like, you know, it's nicer than Rust, I think. And there is like, I think there is like real value in like writing in a language that's, I don't know, pleasing to write in. And that's kind of why I didn't really gravitate towards Rust, and why I have gravitated away from C++. Is like, you know, well, yeah, it's the whole joy of programming thing, I guess. It's just like you want to enjoy what you're writing, and you don't want to feel you don't want to feel like you're getting stabbed in the eyes, for one. Yeah, Rust is hard to read. Yeah, I can't. I look at anything that's written in Rust and I'm just like, what the hell? What is going on? It's worse than C++, in my opinion. I mean, C++ can get pretty crazy. People can really enjoy, like, you know, the scent of their own templating farts. But Rust is just wacky, and it's partly because I just don't know like what's going on in the language sometimes. But I don't know. I think it's a little too crazy. I feel like a lot of people. It just seems like recently a lot of people have been giving Zig a lot more attention, who would otherwise be looking for some of the same things in Rust because they thought Rust was like the only option other than just like C. So yeah. And this error handling stuff is like super nice also. I don't know. I don't really know what it's like in Rust. I hear that it's like kind of nice, but I don't know. But okay, so yeah, we're going to create an instance of ourselves. And this is just a, right, so self is just a struct that represents, so when you make a file in Zig, I described this in the last stream too, but I'll just go over it again because if you're new to Zig, this is like kind of a weird thing to get used to, but it makes a lot of sense. When you make a new file, there's like an implicit top level struct that gets created. So we can define like the layout for a struct in here. And so when I just have this DC block right here, it's just kind of like a bare little field. That's because that's like the only field that we have in our struct of Arbiter, which Arbiter is just an alias for this, which is our top level struct. So we just go ahead and initialize that, and DC block will get initialized by calling the like filter init function. And so that takes an allocator, takes a number of channels. We're just going to hard code that as 2. Oh, we could query the, we could allocate this plugin first, and then like query its number of channels, just to sort of like future proof it. That is like undefined by default though. I don't know if that gets set. When does that get set? I don't know. That's like kind of a little issue that we'll need to kind of clean up in the in the near term, I would say. Defer and error defer are really nice. Yeah, defer is awesome. And it's like, you notice like every language after C++ had that as like their solution for like not lifetime management, but sort of like, you know, stack based lifetime management. I don't know if Go was the first one or if there was something before it that kind of like sparked that idea, but you know, a lot of these new C-like languages definitely take a lot of inspiration from Go, it seems, which is also a really nice language too. So the filter type is going to be we're going to make it a second order high pass. We're going to set the cutoff to 10 hertz and the reso, I mean, who cares? There's actually a nice little helper variable in the math library in Zig that's called, is it 2 square root pi? No, it's 1 over the square root of 2, which is that sort of special Q value that's sort of treated as like the, what do you call it? I don't know, sort of like the center Q value. I forget why that is. I'm not really that much of like an engineer, I guess, but arbiter is not the struct that we're creating, it's an arbiter. Okay, so we make our self, and then you just have to set the plugin's user pointer like so, and then we return the plugin. So now the plugin has a pointer embedded in it to this outer struct that we made that describes all of our plugin specific data. So what we can do, we can make a self, which is a pointer to arbiter, and we can just call plugin get user, and then all that does is just take a type. So it can, you know, cast its internal pointer into our pointer. And now we can access our filter through that. So yeah, what I want to do is say self DC block process. We'll give it the, do we want to take the inputs? Because of the relation of the circumference of a circle and sine. Oh, I know what you mean. I sort of know what you mean. It's like, yeah, it's sine of something. It's like it's 45 degrees basically. And then but depending on where you are in the unit circle, it's like negative or positive, I think. Yeah, but even like how that maps onto the filter is just like, huh? It's, you know, I'm more of a programmer than a DSP engineer, but it's useful to know like how the stuff is derived, I guess. But it is wild, yeah. It all revolves around circles somehow. It's kind of crazy. Yeah, so we can call self DC block, and we'll process the sample that let's process X here and just set it in place. So now we have a DC blocker, hopefully. Let's raise it to like an absurd point so we can like verify that it's working. Not absurd, but let's raise it to like 500 hertz. So like that kick drum won't work. Okay, and this may return an error, so we have to catch it. And I'll just log. We could be a little more specific about these errors for now, but you know. Okay. So let's delete the plugin. double check the audio is coming out. All right. It doesn't really sound like it's working. Might be because I had two instances of it, and so it wasn't actually like reloading the plugin. I'm just going to rescan it just to be safe. And the VST doesn't work. Oh yeah, because it doesn't. We have that error in the parameter code. Okay. Why's it taking forever? Ooh, that's weird. What did I do? I guess we do need to deallocate ourselves. That's like kind of important, I guess. We need to deallocate ourselves. We also need to de-init the filter. No, I don't want to force quit it. What? Hey, whoa, is it really like not responding? Huh, okay, let's just try loading it in Reaper and see why it's not working. $37 gigabytes of memory. Yeah, that's not right. That's not correct. Hopefully that didn't destroy OBS. If it did, you know, for reference, it was because creating the plugin resulted in allocating 37 gigabytes of memory, which may not seem like a lot, but it is. Yeah, what did I do? I mean, these, yeah, like these fatal errors are like no returns. Yeah, why would it be, it's almost like it's just allocating like on a loop or something. just gonna look at the example plugin real quick. Oh, come on. All right, it should be up to date enough that I can check this. Oh, I do need to set the sample rate and stuff. But again, like how would that... I don't know how that would relate to like... Oh. Oh, I didn't change this. That's what it is. The num channels thing. I remember making a note. Oh, num channels is set to undefined by default. Thinking like, oh, I have to change it because we can't use that. Yeah, that's why leaving things as undefined is like not a good default. And this really shouldn't be here. It should be set explicitly, in fact. Yeah, this gets set in like the when like a clap plugin, it gets set in like the format specific wrapper like init function, which is I forget what the order of initialization is there, but either way, this value was not set when we created our filter, so it decided to create so the undefined value in Zig, at least in a debug mode, is like this. So I don't know what that is off the top of my head. It's a large integer, and it's like a very obvious way of like broadcasting that you are that you're programming a bug in your application. Oh my. Oh my. Okay. How are we doing on the stream here? Undefined default values is a bit of a foot gun. Yeah. I feel like you shouldn't be allowed to do it. Like defaulting something to null is fine if it's an optional, because then you're forced to unwrap it. But setting something to undefined as default is kind of crazy. I mean, I guess it'll probably be obvious when you do it, but like, probably is like not a thing you want to hedge any bets on, you know? So I don't know. Now it just like doesn't work. And it could be okay. We didn't set up the filters values, so it'll like mute itself by default. It'd be cool if I could like throw an error if that happened, but if you don't set the like filter in prepare, that like should be like a compiler. But I don't know how I would be able to enforce that. So yeah, you just have to set the sample rate in prepare. We don't still care about the number of frames. Now it should process audio. Okay. And that is what we wanted, which is a high pass at about 500 hertz. So let's set that back to our the value that we want of just like 10 hertz, which should just block any DC from coming through when we start really messing around with bit shifting operations and stuff. So you lose like, you really don't lose like any like audible portion of the sub bass or anything. Okay, so we should be all good to go as far as violently experimenting with our audio. So let's create like an unsigned integer version of our floating point audio. We'll just make it like UX for like unsigned X, and we'll say bitcast X. And we're going to want like a matching bitcast back where we say X is a bitcast of UX. So we can convert back to floating point from whatever we mutate X into. So why don't we do UX equals not UX? And we'll just do a bitwise not of whatever is in there and see what happens. One thing I do want to do as well is like double clamp it too. That is definitely one thing you like kind of need to do if you're working with audio at all. It can be dangerous. You're working with electricity, and it could zap you pretty hard. So what you want to do is kind of, at least on the output, not necessarily here on the input, that's just sort of like, I guess, to clamp our range like within the integer range. Because if we're over it, it's going to not really respect the like integer truncation that we're trying to do. So I clamp it on the input too, but you kind of want to clamp on the output at least. Yeah, and it doesn't have to be 1. You could set like a higher value, like plus 12 dB or something. But you just kind of want to do something to like, keep yourself safe, because you could get like, if you're messing around with bits like this, you could accidentally send an output of like 100 decibels. And some DAWs will like automatically mute that for you, like I think Reaper will, but it's not worth taking that risk. Okay. So this is going to be a bitwise not of whatever our audio is. That's pretty cool. Yeah, that's pretty cool. I don't know if that's too loud. Ooh, huh. So if you raise the bit depth, that kind of gets you like this weird shuffling sort of noise texture. That's awesome. All right, what if we put it on this? Ooh. Wow, that's crazy how much of the like original sound it retains despite doing a bitwise knot. So we're literally flipping all the bits. And you still like retain the notes. You still retain like kind of a lot of the like general impression of the data. It's very cool. Nice. So that could be something that you just like kind of put behind a parameter, right? We would just say like, you know, if we just check if the user has turned XOR on. So we'd create a Boolean parameter called XOR. Default is going to be false. And we don't really need to specify any specific flags, because it'll automatically take care of the like the stepped value, the fact that it's stepped. So we can go ahead and like retrieve that value up here. And we should be able to just retrieve it as a bool like this. And so then we can say if XOR. And like if XOR is not on, let's see what's happening. Oh, did I mess that up? Oh. I actually haven't used a Boolean parameter yet in the framework. So for the time being, I guess I could just change it here. I kind of want to... Ooh, I kind of want to patch that, though. That's going to bother me. I don't have... I don't think I have my key, though. My SSH key. Do I? I think it let me add it last time, but it was like kind of weird about it. Oh. Well, okay, yeah, no, I do want that. Specify a local path. Oh yeah. Yeah, I mean I could just clone it, right? I probably should do that just so I can like develop them in tandem. I think I was just I think just at the beginning I wanted to like show like using the package manager. Yeah, so I probably should do that, but let's just go in real quick and fix that. So min value is 0, max value is 1, default value. You gotta say int from bool, and then float from int. Yeah, and this won't have any bearing on continuous integration, so I'm just going to push this straight to master. because this doesn't get used like in anywhere else in the anywhere in the main repository at least. Okay, let's see. How do you update the okay, no, I am gonna do what you suggested and make it a local path. Because that's just easier for the sake of development currently. And this isn't even a repository for the time being, which is fine. To declare a dependency, right? What the heck? Oh, yeah, what was I thinking? So if I take an int from a float, I can't really, you can't do like int, you can't do bool from int, can you? Bool, yeah, like bool from int. Where is it? They only have int from bool. I don't know what the reason for that is. So what we have to do in the interim, while I not equal 0, I guess. Oh yeah. Yeah, that is. Float not equal 0. Must have a known result type. Okay. Now we should be good, right? Excellent. Cool. We have the XOR parameter. Let's verify that that works. Kind of makes the volume like way louder. I wonder if there's a way we can like compensate for the general volume increase from an XOR operation. We could just like bit shift it, you know, bit shift it by 1, bit shift it by 2, something like that. Back with food. This XOR thing sounds great. Yeah, man. Dig in. Yeah, it's really cool. I'm curious to see what doing other bitwise operations will involve too. Like if we introduce like a state variable, like a previous sample, then we could sort of like we could XOR. Oh, you know what? This is an XOR. Oh my goodness, guys, it's a. What just happened? Yeah, not an XOR. It's a bitwise not. The XOR will happen later when we introduce a state variable. Okay, so let's try bit shifting it like so and see if that like kind of compensates roughly for the jump in volume. That's sick, but also not. I feel like that's bit shifting it. Yeah, if you bit shift to the right, that divides it in 2, right? I guess the problem is then we're kind of like losing Doom 2024 soundtrack. Yeah. I think it's because if you bit shift it to the right, it's like you're also kind of like, you're going to lose like at least 1 bit, whatever bit was at the end. And so that just kind of distorts it even more. I guess we just want to divide after we bitcast back. If not, we'll divide by 2. Okay, I mean that's like it's a bit better of a gain compensation. It could probably be a little lower though, just so it's not like it's still a little like shocking, which is I guess not a terrible thing, but it's not getting much quieter. I guess also part of the issue there is actually no, you're underflowing the rest of the bit process. So you need to be a responsible adult and just compensate for the gain. We'll do it before the clip. But after we convert from after we convert from the integers, min with original. Min with original. I mean that. What would that do? Because that would only clamp it if it's greater. But if you're less than, I don't know. Let's just try it. I'm curious what that'll do. Min of X or Catholic volume to the original. Yeah, I've never tried something like that. It seems like it would get kind of funky because you have polarity. You'd have to take the absolute value. and then negate it depending on the sign, right? But let's just try it out. So we'll have the amplitude, which is the absolute value of x. That's going to be constant. We'll just take the sign too. Yeah. So we'll do the min of x and sine times amp. Just go all positive samples. Yeah, you could. I mean, if you go down to 1 bit, you're just at positive samples, right? But it's either 1 or it's 0. And we could actually just offer a parameter for like whether the user wants to like rectify the just take the absolute value or not, and just be positive, because that does sound pretty cool if you're just screwing up the audio irresponsibly. Yeah. Okay. So the minimum of x and sine times the absolute value. Okay. Unsigned integer types will always return 0 or 1. Okay. Branchless. Awesome. Yeah, let's see what that does. No, not the VST2 is crap. Oh, interesting. Can you hear that? That's like a much more subtle distortion, but it's cool. Yeah, I mean it's a lot less aggressive than what we were doing before, but it's a lot more like usable as a result, I think. That's like hostile. Interesting. That almost like negates it. How is that possible? Oh, because it's just not. It's just giving you the input value back out because we're exceeding it. Yeah, so that's like you can kind of hear like what the result is at that little threshold point there, where it's like it's snapping to the value, the lesser value. That sounds really cool right there. Has this really cool kind of like shaking sound. Okay, I definitely want to include that. But I feel like the regular like the regular operation without that compensation sounds pretty good too. So we could also kind of put that behind a parameter. I don't know what you would call that. I'll leave that out for now. I think we will put that behind a parameter. That's very loud. Okay, so maybe we divide it again. I feel like it's like getting louder. I don't know. Is there something wrong with my mathematical assumptions? Okay, this is unambiguously a reduction in volume, right? I wonder if part of it is because like of the gain compensation that we do here by raising it back by the same amount that the noise floor is, but if the noise floor was set to 0, then I don't know. That's probably gonna have to be fine. There's only so much we can like lower the volume, I guess. I don't know. Why do I feel like that's not getting like any quieter at all? Unless it's just like extremely loud and like the only reason we're hearing anything is because it's hitting the because it's getting clamped. Yeah, like we're reducing the volume by so much. And it's still like pretty loud. Okay, if I multiply it by 0, what happens? If it still makes sound when I multiply by 0, then there's a bug. The bug being that like it's not actually reloading the plugin. None of these changes I've been making have made a difference. No. No way. What am I missing here? We bitcast it back, you know, rescale by the integer limitations and stuff. We scale up by this gain, which shouldn't be like doing anything really. I'm just mystified. It's x times equal, so it is assigning to x. I might restart Bitwig and like make sure it's actually reloading the plugin. Because this is redonkulous. How long have we been going for? Going for almost 3 hours now. Wow. Thanks for those of you who are tuning in. Probably continue this in a couple more live streams. Yeah, and this will probably get released as like an open source plugin, hopefully like in the nearish future. That's crazy. Something screwy is going on for sure. Because we're multiplying it by 0 and nothing's happening. Even if it, yeah, even, I mean, in an integer or a floating point range, that should still completely mute it. If I set it equal to 0, what happens? This is cursed. Is it the clamp? Wait. Yeah, I feel like I'm losing my mind. I don't know. I'm just gonna like ignore it, I guess. Yeah, I mean, unless we just do like I don't know what if there's like an effective way to decrease the amplitude when it's in bit format like this, when it's in integer format like this. Because like you can't divide when it's like unsigned. I mean, we could do a signed integer, and that would like, I mean, it still wouldn't map onto the amplitude. So yeah, that wouldn't work. Hmm. I don't know. This is crazy. I don't know. All right. Well, I felt like when I multiplied it by like 125 there, it seemed to get a little quieter. It was at least manageable. Okay, no, it doesn't make a difference. I don't know why. Probably owing to some sort of black magic having to do with I don't know, integer values and stuff. I don't want to get too hung up on it because whatever. There's cooler stuff we can do than I feel like volume compensation is something that's like so easy to get stuck on for like a weirdly long amount of time. Let's make a parameter called like clamp. And we'll check if it's active. And then we'll do that cool clamping thing. Which okay. Clamp. Yeah. Freudian slip. It's not showing up. Am I missing something? Yeah, I don't know. I guess sometimes Bitwig just like doesn't sometimes Bitwig just like doesn't rescan the plugin. I don't know why the VST2 stopped showing up as having an error either. All right. God dang, dude. All right. This is mysterious. Can I make a float parameter? Could be a Zig caching issue. Maybe. No, because we're still not getting like any, still not getting that parameter. All right, you know what that means. This is this is why you got to implement hot reloading, which I think definitely is something that is like on the list. That just feels like kind of non-negotiable. It's just so much easier, especially like working with audio code. If you're just tweaking one little value, you've got to be able to reload that. So yeah, I do want to provide like an interface for enabling hot reloading at build time, and yeah, you use the take offline in Reaper and then take it back online after compilation, moving the file is done. And that works. Okay, I've never tried that. I literally for years have closed and restarted Reaper every time I change the plugin. Yeah, it's you know, it is what it is. I also, when I first started, I didn't even use like a copy step or whatever. Like, you know, Juice has an option to just like turn on the like ability to copy it to the destination folder. And for a while, I manually copied and pasted the plugin into the destination folder. God knows how much time I lost doing that. I could have watched so many episodes of The Big Bang Theory, and all that time I was spending copying and pasting files. There we go. Yeah, so Bitwig just didn't want to rescan it. I don't know why. I might do Reaper. And it's obviously it's not a float, it's a Boolean. So we got to change that. I don't know why I did that. I mean, it just like gave up on the idea of having another, on the idea of like reloading the plugin. Or like I did something that caused Bitwig to think that the plugin didn't need to be reloaded. I don't know. I think sometimes if you already have it loaded here, it like won't do it. I don't know. Is there an offline option here? I don't know. I don't see one. There might be like some shortcut or something. I don't know. Yeah, I don't know. I just tried like all the shortcuts and it didn't work. Also, it hasn't changed the clamp from a float to a bool. So it doesn't really do a ton if you're at like 16 bits, or if you're lower. Yeah. That's really cool. That sounds really good. That was a cool idea. Thanks for that. Yeah, I don't know if any of these options will like allow it to rescan or not, but okay. So we've got that behind a parameter. Now, I think this would probably be a good time to introduce like a sort of like last sample state. And we'll have to keep one for left and right. I'll just call it Z because that's like sort of the traditional academic notation. There's going to be a slice of, well, it's not going to be a slice. It'll be an array of floats set to 0. So we don't have to set these up anywhere else. Okay. So we have the not. I guess it's like, yeah, I mean, we could do a comparison operation before or after. It'd be kind of cool to experiment with both. But let's try before. So let's say we have like const, let's make an and it'll be x, or sorry, it'll be ux and z at the current channel. Why don't we just set ux to that value? Right, so it's just like hard coded. It's like this is just now going to be this and the last sample. And then we can either store the last sample here, or we can like wait until like right here. So now the last sample is going to equal ux. That's going to be probably a disaster. Oh, yeah, it's going to be a U32. And it's probably not even going to load in Bitwig. Yeah, no, it's not. I don't think that's loading. Let's just, Yeah, let's just make a new project. This will hopefully work. I don't know. There you have it. That is the result of our bitwise and. Ooh, hopefully that wasn't traumatizing for anyone listening. So right, so we're doing a bitwise and with the last sample. It produces basically nothing. Bit depth doesn't, kind of changes it. I think it's just like a little artifact of changing the parameter. Noise floor. We turn on not. Yeah, well, yeah. That's like hard bit noise right there. That's interesting. I'll really clamp it. So that's interesting. So it kind of like smooths it out. That's not like totally destroying. Okay, that's not that loud. Okay. It'd be hilarious if this were just like blaringly loud, but I'm just imagining someone like clicking on this right now and just being attacked. Yeah, that clamp really does a lot. Huh. Yeah, so and doing a bitwise and will interact kind of interestingly with the rest of our parameters. On its own, it doesn't really do anything. So that could be something else we put behind a parameter. We could also do a bitwise OR. And so this takes the bits of one integer and combines them with the bits of another integer, not, you know, not altering any of the v, or it doesn't flip any bits that are positive, basically. And oh, this probably isn't going to reload. I don't know. I should probably graduate to Reaper. Yeah, I can't tell if that's... I think that's different. There's a different quality of the noise there. If you do a bitwise not as well. That's pretty cool. Yeah, this is gonna be, ooh. So I just paused it and it like, it generated a bunch of noise and then like after I paused it, and there's still some DC, which is not good. The reason the and was silent because it started out as 0. Oh yeah. Right, because we're setting the state variable to 0, so it's like, it kind of needs to be initialized, I guess. Yeah, this is already a fun little plugin. And yeah, I was going to say, I actually have some... I was going to say something and then got interrupted by the little noise tail. And now there's no DC, so that's interesting. It's probably just a random... It's just like whatever bit you get stuck on. Initialized to 1 or gets 0. Yeah, that makes sense, I guess. I don't know. I'll try it, yeah. So you need 2 separate state pieces of state, but that's fine. Yeah, and so then like that trailing like DC value is just for like whatever bit you get stuck on, I guess. But doing a UI for this is gonna be cool because it kind of dovetails very nicely with the UI that I did for this, where you've got the like crappy Minecraft font. You've got the crappy pixelated version of the Arboreal Audio logo. So we could do some fun stuff with like lo-fi sort of pixely UI stuff. I've got some fun ideas as far as like doing some kind of visual thing and then like reducing the bit depth as of the image as you reduce the bit depth of the audio. I think that'll be very fun to do. That'll be in a later episode of this saga, but yeah. I guess the last thing I want to try out here is like doing a bitwise XOR. So that'll give you all the bits that don't match. And then eventually we'll probably put each of these operations behind their own parameter. And then on the UI, there'll just be like a button for XOR, for not, for, what do you call it? I forgot the other ones, and, or, those ones. Reduce resolution, color depth, add dither to the UI as you toggle options. Yes, yes, yes. That'll be very fun. I don't know what the UI will be. I guess you could just do a filter on top of it. And it'll have to be implemented in Olivet's, the software renderer, because I don't have, you know, most people would probably write like a GL shader or something, but not us. Palette cycling like in old 16-bit VGA games. That would be cool. I don't really know how that works. Or really, I don't really know. I'd have to like look at that. Like looking at an example. But something kind of like that is what I was imagining. Or just, yeah, that like kind of like crunchy, that crunchy, like low, you know what I mean? Low bit depth color schemes and stuff. Low color depth. Okay, yeah, so XOR. So let's hear how the bitwise XOR sounds. It's terrible. It's an attack. I mean, you could make some pretty interesting like noise music or something, or just, you know, like very harsh industrial music with this for sure. Oh. disgusting. That is nasty, man. Gross. Oh, I love it. That's definitely staying in. Yeah, I think I'm gonna put all those like behind behind their own parameter, and then yeah, I think that's all. I just got stuck thinking about how you would implement like the order of the different bitwise operations, and like it could be interesting to experiment with the order in which things happen and giving like the user control of that. So like if they could drag the operations around. Our UI widgets are not currently capable of that, but that would be a pretty cool thing to implement. First, we have to implement buttons in the sort of like standard library of our UI widgets, because we don't have buttons. We just have sliders and menus. Yeah, and then you'd have to create some way where where the order of the buttons on the screen will correspond to the order that these things get processed in. That would be kind of a little bit down the line. I probably want to just have a UI first and work on that color bit depth reduction stuff first, because that seems a little more fun and easy. And then as far as sound processing goes, one thing I do want to do is like add down sampling. So like reducing the sample rate. So let's add a parameter for XOR, for OR, and for AND. I'll throw all those. It's not obvious like where, like when the yeah, there's so much you could do with like doing these bitwise operations. Like we could store this as its own XOR thing, and then say like if the XOR param is on, then you would do X XORed against, or wait a minute, I'm doing this backwards. No, you would, okay, no, you would process this if the XOR param are on, and that would kind of become your output, and then you could take, you know, like if the OR parameter is on, it's like you could do UX or the Z, or you could do UX or it against XOR. And it's not, I mean, there's no like, there's no right answer when it comes to completely destroying the audio like this. There's almost like too much possibility that we kind of have to like just decide on like what we're gonna do. But yeah, I don't know. I think for now, I'll just kind of like put them all behind a parameter. So if XOR would do that, if OR, we will do this. If you made Z store the original sample instead of mutated, yeah, that would be interesting too. Oh, I can't use OR. Come on. Yeah, I can't use these Boolean values as actual variable names. And then I'll call this bit not too. Yeah, okay, so we've got the different operations in here. In order to test the difference between like state positions, I don't know how you would put it. Let's put that behind a parameter as well. So we'll say like bool state bool state input, which will be false by default. So if we got to get the parameter first. How did I spell it? Capital I. Okay, so if we have state input, the z will equal our input. Otherwise, the state will get stored after it's mutated. Let's just make sure. Okay. Hopefully Bitwig cooperates here. We should see a bunch of new parameters if it worked. Okay, cool. Most of them don't really do anything. Huh. If I switch on state input and I put on and, it's just like kind of normal. Ooh. So if I have state at input and we do not, we get truly a terror. That's menacing. Yeah, okay, so and kind of only like does stuff. If you have stated input, then and. Is obviously, you're just comparing it against itself, right? Yeah, because if self z equals ux, ugh, gross. Yeah, so or doesn't like do a whole lot on its own. Oh my god, it's terrible. It's apocalyptic. And then we have DC. But yeah, I mean, if we do state input, then we're doing these bitwise operations basically against ourselves. You know what I mean? So like XOR does something, and then not is always going to do something. Yeah, it does. In a couple instances, it kind of like, yeah, I don't know. That's awesome. That's exactly what I was hoping for, as far as just like the worst bit crusher anyone's ever made. Should be illegal. Yeah, so I mean, I feel like state input didn't really yield a whole lot because of the fact that it's you know, if you just XOR something with itself, nothing will happen. Or do you do any of these operations? But yeah, I'm trying to think of what I mean. We could like work with reordering stuff, but that would be a whole that's a whole different thing, and that'll involve like implementing UI and stuff and implementing like a very interactive UI. That's probably going to do it for this this inaugural episode of developing Arbiter with the Arbor framework, copyright, trademark, all rights reserved. You are allowed to use the name yourself if you want to mail me $5. No, I'm joking. Thank you. Yeah, definitely check out the library. Let me know how it goes. There's definitely a lot of bugs. I think it's going to be really good though once it gets developed a little more. Yeah, I'll probably be back pretty soon with fleshing this bad boy out and probably doing some other stuff too with the framework. I'm working on VST3. It's not going to be entertaining, so I probably won't broadcast any of that. I mean, nobody wants to see that. But yeah, thanks for watching, and you wouldn't mind watching VST3? I mean, if people will watch it, I mean, whatever. It might help me to be able to think out loud about it. Yeah, the SDK license is it's a motherfucker. Yeah, if you want to implement VST, yeah, because I mean, I'll be learning about how the API works myself too. It's a real, you know, like I said. Yeah, all right. So yeah, that might be, you know, on the docket, I guess. But there's like much more like entertaining things, I think, like terrorizing your eardrums. All right. Store state input. Yeah, it's I mean, yeah, was there a better way I could have implemented the state thing? I'm trying to think of a different position I could put it in. Yeah, see you, man. Thanks for watching. Yeah, it feels like the only spot you could put it is down here. Because it's like, yeah, I don't know. Outside of that, it's like a floating point number outside of that. So but one thing you could do is you have the and it would work kind of like a biquad does. where you have the state, you store the output and you also store the input in separate variables, and then you compare them. You could like add those together or and those together, so that could be like a whole other thing. Yeah, I don't know. You could just rebitcast the original down below. Yeah. Yeah. There's a lot of stuff you could do, I guess. Yeah. All right. But I think that's gonna do it for me, folks. Gonna sign off. Thanks for watching. And it's over.